Hi, everybody. Welcome to our ACM SIGSOFT webinar for today. We'll get started in a minute or two once everybody gets in the room. Um, and fantastic. So let's just wait one more minute just to kind of get going. Right. Okay, why don't we get started? So welcome everybody to the next edition of the ACM SIGSOFT webinar series. This is a presentation that is going to be from Sandeep Kuttal, who is an associate professor at North Carolina State University, NCSU, where she directs the Human Factors and Experience Engineering Lab. Sandeep does a lot of research around human-centered software engineering, combines HCI, software engineering, and AI. She is the recipient of a ton of cool awards, including the NSF Career Award, the Air Force Young Investigator Award. She's gotten Best Paper Awards at CHI, at ICGSE. She'll be talking actually about two of the papers that have won Best Paper Awards and Honorable Mention Awards at different ACM conferences. And much of her research, and including what she'll be talking about today, is all about how to help make sure everybody who wants to be in software engineering is included and can actually perform effectively and efficiently and be successful in this field. And it's really fantastic to see her work and to have her here with us today. Just for logistics purposes, there is a Q&A button on everyone's Zoom that if you have questions for Sandeep, for Professor Kuttal, please type a question into there, and if it's possible for Sridhar and I to answer those questions, we'll do so by text. If it's a question that is for Professor Kuttal, we'll wait until the end of the talk, and then I will read out the questions to her for her to answer out loud. And then for those of you who would like some a kind of attendance sheet, please say so in the Zoom chat, and later, usually about within the week or two, Sridhar and I will process that chat and get you those attendance certificates. Meanwhile, why don't we get ourselves started? And I'd like Professor Kuttal, could you start sharing your screen to get ready for your talk? Fantastic. I can see that, but I'm looking at your menu bar and your icon bar. So, okay, so now it's a little bit better. It's good, but I still see your menu bar, but that's reasonable. I guess it's fine. There's nothing exciting on there, but I see your slides, which is good. And I will let Professor Kuttal take it away and give her talk. She'll talk for about, I don't know, somewhere between 30 and 45 minutes, and then afterwards is when we'll do the questions. So thanks very much, and take it away.
Okay. Thank you, Andy, and thank you, Sridhar, for the kind invitation and introduction. Good morning, afternoon, or evening to everyone joining us today across different time zones for our ACM SIGSOFT webinar. My name is Sandeep Kuttal, and I direct Human Factors and Experience Engineering Lab, and the core mission of our lab is discovering and inventing human-centered solutions for software engineering and AI. So right now, our entire industry is gripped by the promise of generative AI. We are hyper-focused on how fast machines can generate text and syntax. But today I want to pull back our attention to true engine of software development, which is human layer. Our talk today is about making real-time collaboration visible in the age of AI. I'm not able to click. Let me see. Okay. So, starting with the presentation, we have spent decades optimizing, developers' productivity through better codes, framework, automation, and now generative AI. Today, an individual engineer can generate boilerplate code, comprehensive test, and even complete documentation in matters of seconds. Tools like Gemini, ChatGPT, Copilot are helping engineers produce code faster than ever before. If we see, we can say that AI has largely solved the mechanical problem of providing raw syntax. But despite this incredible speed, software systems still are going to fail. Why? Because velocity and alignment are fundamentally different variables. Large language models dramatically increase our speed of execution, but they do not automatically increase our speed of alignment or shared understanding. Teams are now moving faster than they can establish shared understanding between each other. If team alignment is off by even few degrees, high velocity doesn't save you. It simply gets you to the wrong destination much faster. As I often tell my own software engineering students, moving faster in wrong direction is still moving in wrong direction. If we are building wrong systems, generating code at lightning speed does not make it right. And that brings us to the core truth of our discipline. Software is rarely built by individuals. Software is built by teams. Large-scale development succeeds because teams continuously establish and maintain a shared mental model. So, grounded in Olson and Olson's foundational framework on distance and shared understanding, we look at this through the lens of classic 3C collaboration model. If you don't know about it, it is basically to achieve success overall in collaboration, a team must master three distinct human mechanics. One is coordination, which governs how decisions are structured. Another is cooperation, which defines how the actual engineering work is shared between the teams, and is the communication, which dictates how the information flows between team members. And let's be clear, it's not just intuitive concept. Even in the landmark study at ACM 2008, where it was published, Microsoft research, and it was conducted by them, what they showed was that organizational coordination failure predict code defects as strongly as traditional technical complexity metrics. In other words, software defects are often social and organizational problems, not merely programming problems. So usually, the critical challenge in our field is visibility bias. As industry, we predominantly study and build tools for what is easy to observe. So in most of the asynchronous tools that exist out there, or in asynchronous related collaboration we look at, is mostly based on artifacts. And we have excellent dashboards for backward looking, asynchronous artifacts for collaboration. And we can track every commit, pull request, or issue logs. But then there is this invisible traces. And that's what real human collaboration or synchronous human collaboration is, that actually dictate collaborative success also. Like where the attention is directed of individuals, how the decisions are being negotiated between teams, and whether team has psychological safety to speak up. And these are kind of invisible, completely invisible to our engineering pipelines. And I would like to visualize this challenge using the metaphor of collaboration iceberg. So in collaboration iceberg, we know that the tip of the iceberg, the way we can see, the artifacts can be tip of the iceberg, which has commits, pull requests, or issues resolves. So you can see all these. But then there is beneath the surface this whole iceberg, which is harder to kind of observe, and it's unobserved layer of social and cognitive interactions, such as turn taking, psychological safety, inclusion, participation patterns, and shared team mental model. At the same time, every engineer and every AI assistant operate within this local context boundary and seeing only the parts of the system and its assumptions. Collaboration exists as a bridge between these boundaries. And when our tool and process fail to do this gap, goes unnoticed and accumulate over time, and we call it as collaboration debt, which is growing distance between coordination a team needs and what it is actually achieve. So this becomes critical in the era of generative AI, when we have this massive pieces of code in seconds, but the cost of human desynchronization is skyrocketing. The teams need to still understand the code and make sense of it. And if our shared team mental model cannot keep pace with this rapid code generation, then human collaboration depth becomes permanently embedded in the software itself. And the final result is cognitive depth, which is a state where behavioral, rational, and architecture of system are no longer fully understood by the teams or peoples responsible for maintaining it. And if we want to thrive in AI-assisted world, we must move beyond mirroring only visible artifacts. We must observe, understand, and support the invisible collaboration processes which are beneath this waterline. So when teams collaborate in this new AI landscape, they enter this scientific black box. AI does not eliminate teamwork, it intensifies it or shifts exactly where high stake human alignment must happen across the development lifecycle. So most of this synchronous collaboration stays or maybe even is needed more frequently because if we think of even with AI, the things have kind of moved around and they are still needed. Like, for example, before prompting AI, team must establish architectural alignment and decide what context to provide to the model. During coding, they must maintain context alignment so their mental models do not drift apart. And after code is generated by AI, they must collaboratively verify and refine the output. And during production, if the system fails, they must gather in incident war rooms to diagnose and recover those errors. In other words, AI automates artifact production, but humans still have to create shared understanding. Yet, as a field, we know surprisingly little about what happens inside these high bandwidth moments of collaboration. This invisible layer is precisely where inclusivity bugs emerge, which is basically when team members' valuable technical reasoning fails to become part of the collective decision making. So my research is designed specifically to solve these socio-technical problems. It sits at the intersection of human-computer interaction, software engineering, and AI. And our lab pioneers the methods and tools to crack open this black box. So we use iterative way of solving this problem. We discover the behavior and then we invent tools, methods, algorithms to support that kind of behavior. So the idea is that the invisible processes becomes more observable, measurable, and ultimately be supported by AI-augmented world. Because the true bottleneck of modern software engineering is no longer writing code, it is achieving shared understanding quickly enough. So the rest of the talk is to show that how these invisible human dynamics can become visible in collaborative or synchronous collaborative settings. My talk is divided into two halves. The first half will talk about engineering collective navigational intelligence, and the second half will be about engineering smarter collaboration. So these are like Andy mentioned, these are also research papers. Part of second one has a research paper. The others one are still in submission. So I won't get into too much details of that work, but the work which we have published, I will talk a little bit more details about it. So the first is engineering collective navigational intelligence. If we think of as humans or teams or when we work in teams, the intelligence is not with one person, it is kind of with everyone. And collective intelligence create what we create beautifully, creatively together. And the same idea was applied to kind of what about the collective navigation? If the people are navigating separately, what if we can have a shared model or shared the state where we can understand each other's navigation also or can take advantage of that? So that's what this idea was around. And to understand this problem further, I will take a scenario. Um, for example, for distributed engineering teams in reality, imagine Maya is in India collaborating with Scott in US on software project to find a bug. And while debugging, each explores files, folders, code, but they cannot see each other's navigational path until they share their screen, and they're really paying attention to that. For example, if Scott already explored a set of files, Maya may unknowingly repeat the same steps also. And this creates a key problem, which is limited visibility into teammates' information seeking process. And to stay aligned, they must constantly communicate with each other. And this adds cognitive load because they must remember what the other person did or said. As a result, instead of focusing on solving the problem, they spend effort on coordination. And this problem is not limited to software development. It may appear in any collaborative environment, such as gaming, brainstorming, problem-solving systems. So wherever the synchronous collaboration is happening, it can happen anywhere. And in past, this kind of information seeking behavior, where you have to kind of forage through the information, has been solved with a theory, which is information foraging theory. And this information foraging theory is based on optimal foraging theory from animal kingdom. And this theory has been successfully applied across domains such as documents, web, user interfaces, programming environments. And this theory models information seeking as analogous to how humans forage for food. For example, a developer, Maya, searches for a bug trace in the IDE as an information space, navigating through cues such as words, link, code structures to locate relevant information. And this IFT-based computational models, which have been created over time, adopts a rational analysis perspective, simulating how human evaluates the value of information relative to the cost of finding and consuming it. In this view, a rational forager aims to maximize value to cost ratio, selecting the actions that make information foraging more efficient. And this IFT, for years, I have applied to like individual software developers, where I have applied it to different tasks, environments, and code evolution, as well as users. For tasks, creating practical models that capture immediate action trajectory, and predicting whether the developer is searching, reusing, or debugging code. So we have created models around that based on the behavior we found by conducting studies. Second is the environment. Also, we have looked at different environments and looking at these behavior across these tooling ecosystem. It also helped us understand, how people look for information, create models around that. So some of the environments we looked at is GitHub and Stack Overflow, which are standard platforms, but also specialized environments like Yahoo Pipes, MathWorks, MIT App Inventor. And then also the code evolution, moving from a single moment in time to macro scale, tracking how code bases shift, branch, evolve over timeline across entire files or distributed workspaces, and creating tools to support them. So not only we created the models for that, we also created some tools which can help users with that. And we have also looked at users, like almost a full spectrum of developer demographic, from industrial professionals who write code for a living to hobbyists and end users who have no formal training in software engineering background, and down to even novice programmers or students. So across all this, like most of the prior work, whether it was web, user interfaces, programming, and my own work was about individual foraging behavior for interaction. So the idea was the model is based on your own history where you're going to click next. But if we think of like in practice or in real world, things happen in teams, similar to collective systems like bees, ants, wolves. Human teams also coordinate and collaborate together with shared cues and build on each other's actions. And that led us to create a computational model called PFIST that could predict the next step navigation decisions in collaborative environments by integrating social cues. So I will get to what are social cues, but the idea was that the information, like before, it was just the one person, their own history, but now it is the history of your team member as well as what they are saying, their navigational history plus what they are saying. So these were our social cues, and I will get into more details. Our computational model Like what it captured, it's called PFIST. What it really means is programming flow by information sent. And information sent is a term which is used, which is mostly used in uh, IFT. Basically, what it means is what you are thinking and where you're going to go next. So the rational theory, you look at the value and cost. So that's why that's what it tries to do, but for programmers, and that's why we call it programmer flow by information sent. So in order to create this computational model, we used, we had to do two things. The first thing was creating a structured data model. And what structured data model is, we represent the entire software code base, whatever the user is going to navigate as an environmental graph. And each file, class, method, architecture boundary is a node mapping onto the hidden topology of structure. And the edges are the structure, how the links or how they depend upon each other. And then plus we also created an algorithm, which is basically navigation algorithm. So we used the classic PFIS, which was for individual, which was, like I said, it is based on historical footprints of that individual. To predict where they would get next, we added, as I said before, the social cues to look at where the navigation probabilities are across the graph. And we put the social cues directly by changing the node weights, how the nodes weight would change. So that's what the algorithm did. It would change the node weights or will make the decision where the person is going to click next based on that. So we categorized these social inputs. We added it to the data model as it was needed based on the context. And these social cues were like two kind social cues we implemented. One was implicit cues, another was explicit cues. And what we mean by implicit cue is the file, these silent file transitions and navigate traces left by your teammates. So they are normally completely invisible, what they are doing until somebody shares their screen. And then is the explicit cues, what you are saying, like what the team members are saying, the communication. And historically, whatever, it takes more cognitive bandwidth to listen and pay attention to that. So we use these implicit and explicit cues, which were clear, but then implicit which was inside. I see people have raised their hands. Not sure if there is important question or should I keep on going?
You can keep going. There's one question in the Q&A that can be held until the end of the
Okay.
talk, but otherwise just keep going.
Okay.
If your hand raised and you do have a really interesting question, please put it into the Q&A. Thanks.
Okay, I just want to make sure because I saw two people raising their hands. Okay, so like I talked about computational model, as I said before, there's data model, there's algorithms. So we added these social cues as a way, so that the algorithm or model can make predictions based on that. But we also added in algorithm social gating, which we call as social gating. While following social cues, it helps for remote team coverage, promising fixes. So the main idea was that it may not lead to, like the way we add a social cue, it may not lead to herding behavior. So that a dominant engineer gets into rabbit hole and the model blindly kind of follows that path. So, and we took care of this exploration of the algorithm by changing the weights from time to time. And so that helped in making better predictions for our model. And in order to evaluate, we used a real world accuracy for PFIST model. We conducted a rigorous lab study of 30 professional programmers organized into distributed teams of 3. And they were working on a collaborative debugging scenario using JabRef. It is a project or repository, open source repository, which contains 3,000 files. And these participants, they were kind of debugging the task by talking with each other as well as collaborating. They could also share their screen if they wanted. And the GitHub repository, JeffReb, was in Python. And to train the data we collected from that, with these participants navigating through different codes, and total we collected 1,288 method level navigation events, 444 unique files which were visited, 336 conversations, and 577 method level, and 181 explicit code entries via slot labeling. So slot labeling is, if you have AI background, you already know there is intent, but within the statement, when you kind of mark the intent, within the statement, there are these variables which can change. For example, the statement is, I want to go to McDonald's, but the McDonald's can change. So we make it as slot in AI, when we kind of do natural language processing. So those are the slots which I'm talking about, because these were descriptions of the transcripts. So we also put what are the slots, the variables which can change. So what we found was, when we evaluated this, what we found, because what we did was we compared it with the previous model, PFIS-3, which is called. So the previous model, PFIS-3, is for individual foraging, and we created foraging for teams. So what we found, as you can see, the orange one is PFIS-T, and PFIS-3 is the blue one. The prediction increased. It was able to find more navigation steps. And it also improved the prediction ranking. So the accuracy increased if hit of 10, which means the top 10 results, they had mostly what people were looking for. So, and it also improved the accuracy more than PFIS-3. So overall impact of social cue was implicit cues were good at top ranking, and explicit was able to bring more kind of data into top 20 to 50. And when you combine them, it was much better performance, because implicit cues were stabilizing the ranking and explicit were surfacing the additional relevant options. So, coming to the second part, like I said before, so the first part was we created this model which could predict the team when synchronous, teams are synchronously working together, like how their own history and their teammates' history, as well as what they are saying, can be integrated into the model, so that you can easily get where you should click next, which folder or file or function you should click next. The second is a little bit different. This work, it is engineering smarter collaboration, which is kind of similar, but it is additional to that. To understand it, I will like to talk about a little bit foundational spark for this research. So this idea started in 2016 when I looked at this article that human brain is predisposed to negative stereotypes. And I started looking the results. The results were basically saying that as soon as you look at someone, you immediately stereotype about that person. And then I started looking at studies in psychology, cognitive science, and neuroscience. They talk a lot about stereotyping and social judgment. And they also have talked about that when you visually see, you immediately make predictions. But when you are also even on phone, within 20 milliseconds, without seeing the person, you make judgment or implicit biases about their gender, age, and background. This raised interesting question for me. If our brains naturally and automatically form these social judgments, what happens when people collaborate in highly interactive activities like software development? So more than also this, there was also at the same time, there were conversational agents at Hype, like Siri, Alexa, they were becoming mainstream. And I also felt at that time, there was no kind of AI for software engineers. And so the idea was that maybe if we have these conversational agents, they will be less biased for software engineers. And the design of this agent was based on pair programming, that it can switch the roles, and especially it can help people who are in minority, and I will talk a little bit more about it, can easily collaborate with somebody and feel more comfortable about it. So I won't talk about this research at all. This was kind of, I gave a tech talk, ACM tech talk in 2023 in December. So the video is already there. You can check this work out. But today I will talk about the other motivation which came out of this work was when we started conducting these human-human studies, like because before we started creating this conversational agent, we started with conducting human-human studies because we wanted to create this conversational agent as anthropomorphic. So before going into the design, I would like to talk about social identity theory. So social identity theory was developed by social psychologists Henry Tejfel and John Turner in 1970s and 80s. The theory states that humans naturally group themselves and others into categories based on shared characteristics like gender, race, experience level, or even programming languages they prefer maybe. And this creates two distinct psychological groups. One is in-group, which is like us, when you can socially identify yourself with that group. You naturally view them as more trustworthy, intelligent, and correct. You seamlessly align with their actions. And you may have heard of birds of same feather flock together. So similarly, there is out group, which is them, the group of people you perceive as different from you, and you are naturally less likely to listen to or reason or share context with them or follow their lead or not feel comfortable about them. So this social identity theory wanted to kind of put it into global software development. And if you remember, I talked about three C's: coordination, cooperation, and communication. So based on this, we created a 3C framework. And I'm going to talk about this 3C, like how this 3C framework kind of came into existence. Like I said, the 3Cs is for coordination, cooperation, and communication. But as like I said, we started with a study, but this was like for pair programming. When I said human-human studies, we had gender as kind of as 50-50. So basically, we had same gender pairs and different gender pairs. And based on that, we were able to find in-group and out-group, some characteristics which were kind of prominent in them. So we started with a lab study, and then we had conducted surveys and interviews to kind of see statistically if they are significant. And then we had this agent which we created. We also had again balanced gender. So again, at this time I'm using gender as a binary, so people who identify themselves as men and women. So we had two genders only. So the lab study, for AI, and we did NLP analysis also. And then we conducted race studies in pair programming. And this was again a lab study, and we found kind of similar patterns happening. And all these, 3C framework is also inspired from other areas. So it's not just software engineering, it's also inspired from management science, organizational studies, HCI psychology, political science, social sciences, and sociology. And all these, looking at the background, that these are the differences which they have found in other domains, the same differences we are finding in software engineering. And based on that, we created this 3C factors in collaboration. So coordination, leadership style, interruption style, communication, non-verbal cues versus verbal cues, report making. So we had these factors which we found. And then when we looked at, so basically, as you can see, these factors were based on gender, that in group and out group for gender, as well as for race. And then we also looked at age and culture. And most of these factors which we found for in group and out group for gender and race, there was an intersection that even age and culture also could have those differences. So once we created the 3C framework, like being engineer at heart, it was like what we can do, like with this information we found, how we can engineer it. So the first thing we did was we created HCA methodology for effective collaboration. So what I mean by that is we created a HCA method or usability method called remote collab eval, or you can also think of it as a diagnostic method. If you have heard of GenderMag, if you are in academia, maybe you have heard, but it is similar to kind of what was done in GenderMag, but that was for gender. But here what we have is for collaboration. So we created personas, and I think hopefully you can see it very clearly, but the gray area is the elements which you can change in the kind of text. So basically, if you are creating a software for programmers, then you can create the characteristics to be like programmer and domain to be programmer. If it is for gaming, you can change it. But then there is these facets down here, which is coordination, communication, cooperation, which stays same. So that's what the idea is, because these differences are from research. And if they are integrated into the personas, then when you are thinking about like how to evaluate my software, you are thinking from the perspective of persona. So we have two personas created. One is Joe, which is more like one side of the group, and Lou, which is very different from the Joe's personality, so that we can have in group and out group. So either you can have in group if you have Joe and Joe, and you can make it out group if you do Joe and Lou. So these are the sample personas we had. And then we have groupware walkthrough, which was adopted from groupware, although I would call it a specialized walkthrough, because the red portion is the things we added to this walkthrough. So in this case, there is it was again inspired from groupware and then GenderMag, which I mentioned before, their walkthrough, because the beauty of GenderMag walkthrough was that it would also help you think about the fixes, how you should fix your software. So what usually people do is, like, if who can use it, basically software engineer managers, if you have created a software which is for remote collaboration, you can think, instead of conducting a user study, you can take this persona of Joe and Lou and see if you want to see this social identity, out group, in group, and then this method, use this walkthrough and fill out their forms, which here I have abstract, but there are forms which you systematically look at and find the problems in the software, and then you can find it. So we did conduct a study in HCI class, and we had what we found was 6 times more issues were found. So we had a control group and we had experiment group, and on the left you can see the picture. So RCE is our group. So first 5 teams are who were using our method, and then the other teams which used standard groupware walkthrough, which is an industry. And as you can see, our method was able to find more problems, and also people were able to find the fixes for them. And mostly what we found was that usually people were using Joe and Lou terms in order to kind of say that, oh, it is this Joe's authoritative style, and they will like to work alone, or Lou is going to use nonverbal cues. So they were using the characteristics which were in the persona itself. And then also a lot of them said it was well designed and comprehensive, and also it helped them finding more problems. So this is one of the, a methodology. From that, we created a methodology. But since we have these 3C factors, there's also possibility of creating a facilitator agent. And this work is basically what we did was, for Visual Studio, we created a facilitator agent, integrating those 3Cs. So here is we call it as pair equity. So here is the extension icon. And if you click on this, then you can see your own parameters, or your own, how you're pair programming, how the collaboration is happening, and then also for your partner. And it is real-time feedback. And then on the right, you have code editor. If you want to look at it, you can look. Otherwise, you can kind of close also. Then there is also explanation, like if since facilitate tool or agent is going to also mention what what they are doing or how they are doing. So we also have so that their trust in the tool may increase. Research, like why these, what we are showing, it is based on research, and also linking it to the research papers from where it has been borrowed, and also the technical details, how the implementation was done, so that people can make their own decision. So the whole idea around this was that people will be more empathetic towards their partner, and will make maybe shifts through their behavior if they feel that they are not doing pair programming properly. So, so this tool is good for students adopting in classes, or developers. And so what again, like by end of we saw the real time, but we also generate session report once the session ends, then also showing the session report like of your own as well as your partner, so that for future you know how to collaborate better. So when we conducted lab study, people said they found it effective, user experience was better, and it also, some participants mentioned that it motivated them to speak more about their thoughts and take the lead when they felt they were not doing as much. And also, as you can see, the other, they also switched role if they were feeling they were not contributing as much. We also looked or surveyed psychological experiences, which is trust, empathy, and anxiety. And what we found before the session started and after the session started, the trust increased, empathy also increased, but the anxiety decreased for them. And what we found, the tool was mostly helpful because of this collaborative metacognition, because people started thinking how they were working and how their partner is working. And this sparked intrinsic motivation for them to self-improve themselves and the collaboration as such. The other part, which is still in process of kind of properly implementing, is creating educational interventions. How can we teach this for education or for software engineering classes? So educational instruction interventions for instructor, we created these concepts and created educational material. So till now, the small study which we did in the class was more like, what we found was that initially people had high confidence, then when they learned the concept their confidence dipped since they reflected, but once they learned the material their confidence increased again. But overall we still need to evaluate. That's why I said but the idea is that these 3 C's we can integrate it into as HCA method or usability method, and you can check your products, as well as if you are faculty you can also teach in your HCA classes. Second was facilitator agent. Again, it is good for classes also, you can use it in your classes. And if any of you wants to, please feel free to kind of contact me, and I will be happy to kind of talk about it, how we can kind of collaborate and evaluate the tools as well as methods. So what next? The next decade of software engineering, what I would say is that we have to recognize the limitation of AI boom. Generative models require massive historical artifacts, but mostly asynchronous to be trained. They look backward on the digital footprints, what was left yesterday. But synchronous collaboration live completely in now. It exists in real time, turn taking, file navigation patterns, or pauses or psychological safety in live sessions, synchronous sessions. And current AI systems have extremely limited visibility into social processes that produces software decisions. And there is no idea why a decision was made, who was left out of the conversation. If teams are misplaced, they can provide incomplete or conflicting context to AI systems, which may accelerate the production of poorly aligned software artifacts. And the solution to this problem isn't always to build an even bigger and more complex model. Sometimes the smartest engineering solution is to design lightweight, precise, socio-technical tools that make our human dynamics visible to us. So for past 40 years, the defining question of software engineering was, how fast can we write code? And in this new era of AI, that question is no longer sufficient. The new defining question will be, how quickly can humans achieve shared understanding? The future of software engineering will not be determined solely by intelligence of our machines, but by our ability to achieve shared understanding despite their speed. And none of this work would have been possible without the incredible dedication of my graduate and undergraduate students, as well as generous support from funding agencies. And thank you. And now I'm open to having any questions.
Fantastic. Thank you, Sandeep. I'm going to bring my view back. We have a number of questions on the Q&A, so I will ask those to you. And otherwise, we have about 15 minutes before we're going to end the session. So David Varon would like to ask, how do these collaboration risks, which I think was talking about early on in your talk, how do they change with team size?
That's a very good question. So I haven't studied, so I won't say that, oh, I have a facts about it. But the studies we did was with two people because that's the smallest unit of collaboration. Because we did pair programming, so the smallest unit of collaboration is pair programming, and there was a reason for doing that because we really wanted to kind of look how people are collaborating together very closely. So there is a possibility a lot of these factors may not be for big teams, but I feel to some extent they generalize to bigger teams because if you are a minority or out group, you will be even more uncomfortable if it is a bigger group of out group people, people who look very different than you. So you will have even more hard time kind of talking with them. I think one to one is a little bit easier. So I do feel there should be a correlation of team size versus how they are going to interact. But even as I am saying, if I think of management studies, they looked at bigger team sizes and these differences were still there. So coming from research for software engineering groups, I have looked at two team size, but in other domains, they have looked at bigger team sizes in industry. So these differences still exist, whether it is a small team size or a bigger team size. That's what I would say.
Okay, thanks. Actually, in relation to that and relative to a few questions that are in the Q&A, does Gen AI forecast the shrinking of team sizes now that one person can work with 200 bots and create the same amount of work that it took 200 software developers to do? And if does that end up in the limit having companies of just one software developer, in which case then maybe there isn't a need for shared understanding because there's only one person?
I think like what I have when I talked with the people from industry, a lot of them are also doing code comprehension together. Um, So, it's, and more I don't see as collaboration going away because requirements you need to get from people, design, you have to talk with your teams to kind of create better. Somebody has to check it, somebody has to verify it. Yes, implementation or mechanical code has been produced, but if I myself look at the way AI kind of responds, you cannot really trust all the code which it also gives. You have to kind of look at it. Maybe the models will become better, but remember the code which is being generated, it depends upon what model has learned. So whatever code is generated out there, it is learning from that. There's nothing new create, the creativity and other parts, where really a new problem has to be solved, humans are still needed. And again, if I see from testing, integration testing and all, that needs to be for bigger, for more people to kind of look at. So I understand the question, the this race which is going in industry to just produce faster code. But we don't know what will happen in next 3 4 years once the things start crashing. Uh, but yeah, so that's what I would say about around that. I think collaboration is still important. It is still gonna be important. No matter what, humans are still very important layer. Either they are using the software or they are producing the software.
Awesome, thank you. That's a nice answer. I want to believe you. And but I do agree. We're in the middle of a disruption, and we'll see how things play out in the next 3 to 4 years, and what shakes out at the end. So another question from Luigi Scorzato. Great insight. Your emphasis on shared models across different team members. This is about the middle of your talk. And social dynamics may suggest that a simple solution could be to have a single human that defines all the requirements for AI. But I believe the problem is deeper because AI itself does not have a single consistent model. What do you think?
I know that a lot of time, it may sound like, especially when I talked about having an agent also, which I talked about, like creating an agent. Um, So it sounds like I am kind of pushing towards that, oh, we don't need humans and AI is the main. But no, like, if we think of solutions like I think it was around that only one person is needed, isn't it, for requirements? That's what the question is. Can you repeat the question again? I think I lost that.
Yep. All right. It is. I'm trying to
Yes,
find it.
sorry about that.
Where did it go?
I think it was maybe like what I understood was that, oh, like only one
Oh, yeah.
human can
Yeah, so it
hold
says
all
your
the
emphasis on
resources.
shared models across different team members and social dynamics may suggest that the simple solution should be to have one person who defines all the requirements for the AI and nobody else talks to the AI.
No, I mean, like, requirement engineering is, or requirement engineering as well as, like, I would say UX, like, since I'm a CI person mostly, human factor person. So for me, humans are very, very important in whole, like, equation. So I don't think one person can do requirements because you have to talk with the domain people. Like, and this is like if you have taken software engineering classes, we always talk about this agile development. That's why, like, that the requirement keeps changing of your customer. So you can't just kind of use one AI and then make the decision. You have to talk with the customer. As a developer, you have to talk with the customer. So still there is this, like, talking with people and synchronous kind of collaboration which is going on. Maybe that also can be like if the customer is not feeling comfortable talking with you, or you are not feeling comfortable talking about the questions, so still, like, these kind of characteristics can help. Because like the HCA methodology, if you think of it, is for any product, like, whether it is Zoom, it is Microsoft Teams software, like you can check the inclusivity bugs in all of them.
Hmm. Thank you. All right. We've got another question from Wilhelm Fitzpatrick. Can you give a few concrete examples of how implicit cues are communicated between members of a team?
Oh, so I do have slides. Uh, let me see. So this is like data model. So basically, like, if you see, uh, if I say this is Scott's navigation path, Scott went on these functions, and this is where he is currently. So what we do is we create this graph, which is nodes and, like, and these are basically the queues. So this is how we show uh, the graph of nodes and queues, and you start adding the queues based on, now for social queues, if it is implicit queue and your team member Maya is on draw triangle, then there will be edge which is created between this draw triangle and between where it is connected. So basically based on this, because this is added to your algorithm, the weight can change. And similarly, like, this is Scott. Now the explicit communication of voice happens, and where Maya said draw a triangle and then set color. So all the cues related to what she said will be kind of added to that graph. And then when the algorithm is going through it, it will put the weights accordingly.
Okay, thank you very much. All right, next question. Um, do you feel that the tool you've created, this facilitator tool, can be used to maintain the oral tradition of software engineers or software engineering? This is from Sean Raybold.
Um, which means oral tradition means that they keep talking with each other.
I'm going to guess, unless Sean would like to clarify. If you do, raise your hand, Sean, and I'll let you speak.
So if it is about, like, since facilitator agent is for pair programming, and in pair programming, you are supposed to talk so that the other person may know what is going in your head, how you're solving the problem, because there is not explicit learning. There is also this implicit learning, which you just learn, like how the person behaving as well as explicit. So I feel like, yes, it will lead them to talk, because if they are not talking, they will feel. But at the navigation stage, like, the talking may be less because, like, sometimes you have to let the other person work completely of their own.
Hmm. Now, Ravindra Naik wants to add a component to this question. By implicit cues, do you mean the judgments that are made by each team member in the context of their own task? While these may come from
No.
navigation of a website or
No.
something, they also might come purely from their own thoughts and analysis. They might not even have realized that they've made a decision. How do you measure or record this?
So I will take it back. So implicit, so this is confusion between the first talk I gave, which was engineering collective navigation. There implicit was wherever you are clicking, basically your actions. Your actions on the IDE is being recorded or basically is being kind of collected. So for the second one, I didn't talk about implicit because the question is more related to the second one. To some extent, the way there we did was, I forgot to mention, but it is multimodal kind of a tool or facilitator agent. It takes what you are saying, it takes what you are typing, your actions, what you are saying, as well as your facial expressions for self-efficacy and all. So whether the person seems confident or not confident in, and kind of measuring that also. So implicit, was different for the first part of the talk. The second part, I didn't talk about implicit as such.
Okay, thank you. Um, Now we've got, I guess, a pretty high-level question here from Pilar Gomez Gil. Um, Many software companies are making it mandatory that every programmer uses AI, even to code really easy things. Do you think that's a good idea?
Um, I mean, what I feel, if it increases your productivity instead of you remembering that simple code, then it's great idea. But wherever the productivity is increased, it's easy for people to kind of do. That's great idea. But if it is being forced when the answers are not correct, maybe then it is not a good idea. If the code is generated like 1,000 lines of code and you are not checking it, what AI generated, then it is a dangerous idea, especially for self-driving cars. but yeah, so yeah. I mean, I would say, I personally also use it, a lot of times. And that's why I said, a lot of time it gives very incorrect answers. But it also helps to increase productivity, but at the same time, you cannot trust each and every thing it is telling you. You have to use your own common sense and so yeah. So I would say it is great idea for simple things, even the complex things. If it's solving, great idea as long as it is correct code.
Do you encourage your students to use AI to code?
Luckily, like in HCA class, I didn't need it to, and nobody was using. Somehow, my students, I don't think they are that much kind of in university level. I haven't seen, I think in my classes at least, but it is the human computer interaction class. So they haven't used, but I don't know, in other classes, I'm sure they are using it, and especially the younger generation.
What about
So I
your
would,
what about your PhD or master students?
yeah, they are using it. And
And
I encourage them to use it also,
okay,
actually.
that's very
Yeah,
cool.
yeah,
Um, I like that. I mean, I use it, my students use it. Sometimes they shouldn't be using it, but I think it's a problem when it substitutes for your own critical thinking.
yeah.
And it's, I think right now the user interface kind of encourages that. Just do
Mm-hmm.
it for me, and I don't need to think about or look at what you just did. Um,
Mm-hmm.
but that also makes it then difficult to incorporate um, Gen AI as one of the, let's say, collaborators, as you've been kind of studying in terms of like, is a pair programming partner, should that be AI? But if you have a group of people, should any one of them be an AI that you might want to talk to? Because it's not going to give the same signals to the rest of the humans.
Mm-hmm.
The human signals
Yeah.
are to go ignore, mostly probably get ignored.
Mm-hmm.
What do you think about that if you added an AI to a team? Do you think this kind of facilitation tool would still work?
I mean, I think to some extent, what I was also trying to say was there is a possibility that AI can also look at this aspect of how people are behaving, whether it is clear or not. Because if we give most of, we type, it loses the context in which context we are saying. Isn't it? When we, as humans, understand the language, there is what are the words we are focusing more on, where we are putting more attention to. There's this whole dynamics, or like, the same word may have 10 meanings, different meanings. So what I personally feel like, the voice and like this other multimodal inputs are pretty interesting to kind of enter to make the model even more better.
Okay, thank you. Well, we're out of time, so I want to say thank you again to Dr. Kuttal for your wonderful presentation, really cool ideas. I even have some ideas of my own that I'm going to talk to you later about.
Thank you.
Um, and we had a large number of people here. Again, if you wanted a certificate of attendance, please, and have not asked for it in the Zoom chat, please do that. Sorry we didn't get to all the questions. There were two questions that might be relevant. One is, are your slides going to be made available? And another question that was related to that, which is, there are some really cool references you've made in your slides to papers and talks that would be lovely if you could find a way to post that, let's say on your homepage or something.
Yeah. I mean, although those my papers are there on the website itself, but I will make the slides available to you maybe.
Okay, great. And I can get them posted onto the SIGSOFT page where we advertise your webinar.
Sounds good.
All right. Well, thanks again, and I hope everybody has a good morning, evening, and night wherever you happen to be. And thanks very much for coming.
Thank you, everyone. Bye.